Welcome to AI Decoded. It's that time of the week when we'll look in depth at some of the most eye-catching stories.
When NASA's science team began analyzing what could be Voyager 1's final transmission ever, they thought they were closing a chapter. After nearly 50 years in space, Voyager is dying slowly. Power is fading. Instruments are being shut down. Every signal that reaches Earth now could be the last full dataset humanity ever receives from the edge of interstellar space. This wasn't supposed to be a discovery. It was supposed to be preservation. Archive the final measurements, validate the readings, add one more page to history. Instead, as engineers and astrophysicists examined Voyager's last clean data packet, something unsettling emerged. A subtle directional imbalance, a distortion in the outer boundary of the sun's influence, a signature that didn't quite match the models. And when they overlaid that anomaly with long-standing simulations of the outer solar system, one possibility resurfaced. A possibility astronomers have debated for nearly a decade. There may be another planet out there, far beyond Neptune, far beyond Pluto, far beyond where we thought the solar system truly ended. And Voyager's final whisper may have just hinted at it. To understand why that matters, you have to understand where Voyager is. In 2012, Voyager 1 crossed the heliopause, the boundary where the sun's solar wind gives way to the interstellar medium. It became the first human-made object to enter interstellar space. Out there, the sun's magnetic bubble, the heliosphere, interacts with the galaxy itself. Voyager measures plasma density, cosmic ray intensity, magnetic field orientation. These aren't planetary instruments. They don't take pictures. They don't scan for worlds. But they measure structure, and structure reveals mass. For years, astronomers have been puzzled by something strange in the outer solar system. Several distant trans-Neptunian objects, icy bodies orbiting hundreds of astronomical units from the Sun, share clustered orbital alignments. Statistically, their orbits should be random. They aren't. Their long axes point in roughly the same direction. Their inclinations show patterns. Their perihelion clustering defies simple explanation. One possible cause? A massive, unseen planet. The hypothetical Planet 9. Estimated mass, 5 to 10 times Earth's. Orbit, highly elongated. Distance, possibly 400 to 800 astronomical units from the Sun. Too far and too dim to detect easily, but massive enough to sculpt distant orbits through gravity alone. Voyager wasn't searching for Planet 9, but it was measuring the shape of the heliosphere, the vast bubble created by the solar wind pushing against interstellar space. In idealized models, that bubble should be roughly symmetrical, compressed slightly by the interstellar wind, but predictable. Instead, Voyager's final dataset suggested something subtle. The magnetic field lines beyond the heliopause were not aligning exactly as expected. Plasma density gradients showed a slight but persistent asymmetry. Cosmic ray intensity distribution appeared uneven along a specific axis. On their own, each of these could be explained by interstellar turbulence, but together they hinted at something directional, something influencing the outer boundary from within the solar system itself. Gravity shapes everything, even at enormous distances. A massive object in the far outer solar system would not just perturb icy bodies in the Kuiper Belt, it could influence the shape of the heliosphere over time. Not dramatically, not like a wrecking ball, but enough to create measurable distortion. When NASA scientists compared Voyager's directional asymmetry with orbital simulations that include a hypothetical Planet 9, the alignment improved. Not perfectly, but noticeably. The direction of heliospheric distortion loosely matched the region of sky where Planet 9 is predicted to reside. That doesn't prove anything, but it narrows the question. There's historical precedent for this. Neptune was not discovered by accident. It was predicted mathematically. Astronomers noticed irregularities in Uranus's orbit. They calculated the gravitational influence required to explain it. Then they looked, and found Neptune exactly where math said it should be. Planet 9, if it exists, would be far more distant and faint, but the logic is similar. An unseen mass reveals itself through gravitational fingerprints. Voyager's data may represent another fingerprint. There is caution here. The interstellar medium is complex. The Sun moves through it at roughly 230 kilometers per second, passing through varying magnetic environments. The heliosphere itself changes over the solar cycle. Models are imperfect. Data from a single spacecraft provides limited geometry. Voyager 2 crossed the heliopause in a different direction and shows variations that complicate the picture. This is not confirmation. It is suggestion. But suggestions matter, especially when they arrive in what may be the final scientific voice from interstellar space. Voyager 1 now lies over 24 billion kilometers from Earth. Its radio signal is unimaginably faint. Its power supply, 3 radioisotope thermoelectric generators, continues to weaken each year. Instruments have already been powered down to conserve energy. Eventually, even the transmitter will fall silent. When that happens, there will be no restart, no reboot, just a spacecraft drifting forever between the stars. Which makes its last data precious. Every byte is historic, every anomaly worth examining. Because once Voyager stops speaking, there will be no more direct measurements from that distance for decades. The idea that there may be another planet out there is not science fiction. Wide-field surveys continue searching. Infrared telescopes scan candidate regions of the sky. Simulations refine orbital predictions as new trans-Neptunian objects are discovered. The search space is enormous. If Planet 9 exists, it is cold, dark, possibly shrouded in faint reflected sunlight, barely detectable from Earth. Voyager cannot confirm it directly, but its data may have quietly reinforced the possibility. When NASA's science team analyzed Voyager's last clean data ever, they weren't celebrating. They weren't making announcements. They were modeling, testing, rerunning simulations late into the night. Because if a massive planet truly lurks in the far outer solar system, it would change our understanding of how planetary systems form and evolve. It would mean our solar system is not 8 planets and debris. It would mean we missed something enormous for decades. Voyager 1 was never meant to search for hidden worlds. It was sent to visit Jupiter and Saturn, to photograph moons and rings, to then drift outward as a silent ambassador. Yet nearly 50 years later, its final whisper from interstellar space may be nudging humanity toward one more discovery. Not with an image, not with a dramatic signal, but with something quieter, a distortion, a misalignment, a pattern that doesn't quite fit. And sometimes that's how discovery begins, not with what you see, but with what doesn't align. Somewhere far beyond Pluto, far beyond the frozen